Look up at the night sky. Every point of light you see has a story. Our sun and the countless stars scattered across the Milky Way all had a beginning. But a star does not begin with light. It begins in darkness. Deep inside enormous cold clouds of gas and dust, called molecular clouds, gravity is quietly at work. These stellar nurseries can stretch across many light years and contain mostly hydrogen mixed with dust and other material. For thousands, even millions of years, some regions of these clouds slowly become denser. Eventually, the gravity begins to win. A dense region starts collapsing inward, pulling more gas and dust toward its center. As the cloud contracts, it begins rotating faster. The center becomes denser, hotter, and increasingly compressed. Hidden inside all that darkness, something new begins to form. A protostar. It is not yet a true, stable star. Gravity continues feeding it, drawing surrounding material inward. But that material does not simply fall straight into the center. Much of it forms a rotating disk around the young protostar, called an accretion disk. And then something spectacular can happen. Powerful jets of material can shoot from opposite sides of the young stellar system, crashing into the surrounding cloud. The protostar continues growing. More material falls inward. Pressure rises. And deep inside its core, the temperature keeps climbing, until eventually something extraordinary happens. Nuclear fusion begins. Hydrogen nuclei start combining to form helium, releasing enormous amounts of energy. After a long journey through darkness, a star is finally born. Indeed, the newborn star begins a much longer chapter of its life. Gravity continues pulling inward, while energy produced inside the star pushes outward. When these forces reach a stable balance, the star enters the main sequence. Our own sun is currently in this stage. But the story around a newborn star does not necessarily end there. Gas and dust left inside the surrounding disk continue orbiting. Tiny particles collide, stick together, and gradually form larger objects. Over millions of years, some of this leftover material may eventually become planets, moons, asteroids, and comets. A star has been born, and around some stars, an entire planetary system begins taking shape. Today, the James Webb Space Telescope allows astronomers to peer through cosmic dust, revealing young stars that were once hidden from our view. Webb can observe stellar nurseries, protostars, disks, and jets, helping scientists understand different stages of star formation. And this story is not only happening somewhere far away. About 4.6 billion years ago, our own sun began through the same fundamental process. A cloud collapsed. A young sun formed. Think about that. And material surrounding it eventually helped build the solar system we know today. Every sunrise we see began with a cold cloud of gas and dust billions of years ago. And somewhere in the Milky Way, hidden behind another dark cloud, new stars may already be forming. Follow beyond the unknown, because next we'll discover what happens when a star reaches the end of its life and why some stars die in the most violent explosions in the universe.